they say, we don't have it here. We're hosting it in the cloud. Okay? So there's some studying on your side, and you have to get used to when I say study about this, you have to study because that's the reality of an IT company. They're not going to teach you step by step with quizzes and assignments. You just have to jump on it, read it, and do it. Okay? Any other questions? Alright. So, if you want to take that CERT exam today also, we complete the knowledge, but you have to read that book because there are lots of details in it, and there are lots of tests in it, which is tricky tests. It's not straightforward. But as I said, it adds a lot of value to your resume. Okay? So your chance, let's say you have 50% chance to get a job, it goes up to 80%. And don't worry about that $200 because it's peanut compared to what you pay to Georgia State, right? So far. So don't bring the equation of the cost at all here, all right? And the Scrum, as I said, if you go take a Scrum or SAFE cert, that adds value to SAFE or Scrum.
Can you tell us which one? Because there are so many.
SAFE is better because it's for large-scale companies. And of course, if you learn from large scale, you can apply to small cases.
No, but when you try to, there are all different kinds of SAFE and Scrum too.
The beginner one, what is that? Associate or what is it?
You know, some of them cost less, but you will have to pay a fee, like a renewal fee.
Every year you have to pay a renewal.
Okay.
That's, I think it's $100 a year.
But it depends. Some of them cost like $1,200, but then you have to pay $50, and some of them cost $600, and you have to pay like $200. So I was wondering which one.
Well, you don't renew it. Yeah. Simple. If that's a costly thing for you when you got your job and using that for leveraging of getting a job,
yeah,
then you don't renew it. The whole intention is to get your first job. After that, there are lots of things that you can do, you cannot do, or you can upgrade, you don't need to upgrade. Eventually you have to upgrade all the time, but it's not mandatory really. At this point in your life, it is sort of mandatory if you want to get a good job. You have to compete with others. Market is good, yes, but other qualified people are there too, so you have to compete with them. Learning this course and going get the cert and the other cert, it adds value, and don't be surprised, suddenly you might get a job in a very good company. My mobile students, they are getting jobs, alright? And one got just a job in Accenture. So, and your life will change, as I said. If you get a job or not having a job, it's like 1 and 0 game, alright? I wish government would give you money if you didn't have a job, but not this government. Not, I don't mean this government, in general, U.S. government, alright? Do they pay in Brazil or not? No. If you come from Europe, they pay you. But here it's capitalist, you have a job or you don't have a job, alright? Okay. So, abstract class. Did we talk about abstract class?
Yes.
Okay. So what is the point of an abstract class?
Extend it to
you create methods which can be used to
pay if you don't have a job.
if you don't have a job.
So that you can implement.
Abstract class is classes that you don't know usually some of the methods how to implement, and you leave that to the children to implement because the children know how to implement that. The example was geometric object because get area of geometric object is too broad. You can implement it for every geometric object. So you make that an abstract, and then you extend from that and leave the children to what? To implement that. Can you have an abstract class with no abstract method?
Yes.
Yes. Does it make sense?
No.
Not much. Can you have a class, if you have a class and you have an abstract method, should you declare that class as an abstract?
Yes.
Yes.
Can you create an object from an abstract class?
No.
Can you have it as a type folder?
Yes.
I'll watch the video.
That counts too.
Which video? Ah, okay. Alright, so abstract class, as you can see, this is an abstract class and these are the inheritance.
We don't see it.
Oh,
Yeah.
here you go.
Our camera has.
Where is your?
So you have an abstract class and you have an abstract methods here. As you can see, abstract methods are clear based on the tilt, right? So these are abstract methods, and as you can see, circle and rectangle extend, and definitely they implement the get area and get perimeter, right? Can you have a child which is also an abstract?
Yes.
Do you need to implement those methods anymore? No, if you make a class, child class, and it's abstract, it's up to you. You can implement, but usually you make it abstract because you don't know how to implement it. Now, if you have another child class under this, and if it's not abstract, what will happen? You have to implement all the abstract methods all the way to the parent, top parent class. Otherwise, you cannot make it non-abstract. Okay, we good? So we discussed abstract, then we go to the, and there's tons of them in the Java JDK, because lots of classes, there are methods that you don't know how to implement. Calendar is too broad again. We have different type of calendar. So I make the calendar abstract, and I leave the children to implement specific ones about the what? Calendar, right? All right, then we got to the, by the way, you see the time, you see the calendar? Calendar or Gregorian calendar are used for getting the time, the date. In the Java 1.8, there are specific date and date time classes for dealing with date and time. If you're taking the CERT exam, you have to get familiar a little bit about that. Because this is a bit difficult to deal with date and time, but those date, time, and date time classes for Java 1.8 is easy to deal with time and date, okay? So maybe you want to take a look at that one. Interfaces. Now, we have abstract class, we understand. Now, interfaces. What is an interface? So I'm going to give you an example here. Interface, it is like an abstract class with one big semantic difference. Okay? So let me create a fruit here. And it is a class. Alright, so fruit is a class, right? Now, I'm going to create an interface. Now, let's discuss the interface. First of all, I say edible, for example. So it's an interface. So what is the syntax? Public, interface, edible, or whatever you want. Are we good so far?
Yeah.
Now, this is before Java 1.8. I'm going to tweak it a little bit for Java 1.8 and after that, alright? All properties should be public static final. All the properties should be what? Public static final. You already know what final means, right?
Yes.
You already know what static means, right?
Yes.
Alright? Now, all methods are abstract. This is before Java 1.8, okay? Then I'm going to revise that for Java 1.8 and after, right? So that's the interface syntax. All the properties should be what? Public, static, final, and all the methods should be what? Abstract. So let me put just one method here. Public void how to eat. Is that an abstract method? So it's good for an interface, right? Okay. Now take a look here. Fruit. Implements edible. Alright, so see, it is like an abstract class interface. In abstract class you say class circle extends what? Geometric object, and you implement what? All the abstract methods, right? Here is similar thing. The fruit implements the edible. Now fruit should do what? implements all the abstract method of this interface. What is the abstract method of this interface? How to eat, right? So even Eclipse will help you. You have an error here, right? Why? Because you have to implement. So you put the mouse here and says, add the unimplemented method, and it helps you to get rid of that compilation. So did I implement how to eat now? Yeah, but this is empty, right? It doesn't have anything here, right? So we good so far? Now, there is a problem here. What is the problem? Fruit. Do I know how to eat any type of the fruit? Maybe some of you just open your mouth and dump the fruit in it. But usually that's not the case, right? Based on different fruits, you eat it differently, right? So, it means maybe I should not implement that, but then I have a problem with the fruit, right? So how can I fix that? Public abstract class fruit. So I made the class fruit abstract because I didn't have any other choice, because I implemented this interface and I didn't want to implement the how to eat. So the only choice I had to make this class abstract. Now I leave it to the children to implement what? How to eat. So I come here and say apple. Apple extends what? Fruit. Is fruit is abstract method, a class.
Yes.
Should I implement all those abstract methods? If I go through the chain of hierarchy, which means I go to interface, I look at the fruit, how many methods I have there to implement? Only one, how to eat, right? So I'm going to implement that, and I'm good. And I say, system out, int line, in the skin, and eat. Like that. Some of you eat the apple with the skin, right? That's fine.
That's where all the fiber is.
Huh?
It's
That's how you eat it.
It's what?
It's where all the fiber is.
Yeah, and all the poison is there too.
Yeah, but everything we eat is poisonous.
They found out in a non-organic apple there are at least 50 different types of pesticides in the
Yeah.
skin.
I like those.
That's what makes that distinct taste.
Wait, you don't eat an apple like normal?
The skin of the apple.
But you don't eat it like, you don't bite into it like normal?
Me?
Yeah.
I do, but I buy the organic.
Oh.
With the 50 different pesticides.
No, there is
The
no.
organic.
It's organic.
Go to Peru if
But
you
you
don't like
just said
pesticides.
You know, if you think about it,
Non-organic.
if you think about it, all apples are organic.
They're not organic.
They are organic. They're all organic.
They're not.
They are.
Get me a program right
It's
now.
organic material. It's all organic.
Oh, you think the pesticide they use is organic?
It's all organic. It's all organic material. Think about it.
They're not organic, that's what I'm saying.
It's all organic material.
The pesticide is synthetic material, it's not organic.
It's
Oh, yeah.
all
Can you go back to the
Okay,
the
you
edible
eat
class?
all the skin of apples non-organic, alright? Good luck. I talked to you 20
He's
years
not
from
hungry
now.
today.
Hopefully I
To sell
I
it-
still talk to you 20 years from now.
To sell an
That's my apple skin.
What I'm saying is, to sell an inorganic apple means it's not actually an apple.
What?
If you sell an inorganic apple, it means it's plastic. It's not actually an apple.
It's
No, non-organic apple doesn't mean something
Okay.
wrong with the apple. It
I'm
means
talking
they-
chemistry.
No, let me tell you something.
oh my gosh, coding.
About, no, this is more important than coding. It's about your health.
You can't program anything for dead.
Non-organic apple means there is nothing wrong with the apple. They use a lot of process and chemicals that is non-organic and is sitting on the apple. That's why it becomes non-organic apple. Lots of synthetic pesticides, which is banned in Europe, they're still using it in the United States.
Facts.
Why? Because it's cheaper, and unfortunately people don't have an education of food that much here. They just eat, doesn't matter, but their phone should be the best one, alright? Yeah, food is the problem.
What I'm
And if you
saying
study, you will figure out what's
is
going
that
on.
each apple is both organic.
Huh?
Because they're organic material.
Yeah, but there's another discussion too. Sometimes they genetically modify the apple and other stuff. which makes it non-organic,
So
right?
like corn, is it?
Yeah, it's genetically modified and
Yeah.
not supposed. So yeah, be careful about food, alright? Alright, that's it. So peel the skin and eat it. Or maybe I should say peel non-organic apple and then eat it, alright? So are we good? So apple extends from the fruit. Fruit is an abstract class and it implements from what?
Why?
But
Can
I'm
you show me
edible.
what your edible class looks like? I'm getting like a error.
Edible is an interface.
Yeah, you have
Not
to
a
create
class.
What do you, oh, okay, public interface edible. Okay.
Yes, interface, right?
Yes.
Now, so everybody understand, the interface, only public static final as a property. All the methods are abstract. You can implement, a class can implement interface, but if the class needs to be non-abstract, it should what? Implement all the abstract methods. Alright? Now what is the difference really, except the syntax which we know? For example, in abstract class, you can have abstract methods and you can have non-abstract methods, right? And you can have properties which are not public static final, right? But what is the semantic difference? Why I cannot come here and say class and come here and say, where is the food? Extend. Where is my
Java Jesus. Java Jesus.
public abstract, sorry. Right. Alright, so this works or no?
It should work. You gotta turn that into brackets.
Yeah,
You gotta turn that into braces.
You have to change this to a.
Method. Braces. Oh.
Oh, sorry, you have to put abstract. Okay, so that's one of the syntax difference also. In abstract class, you have to put the keyword abstract. In interface, even though it's abstract, you can put the abstract keyword, but if you drop it, automatically interface will put that because all of them are abstract. So it knows that, yeah, everybody is abstract, right? Alright, so can I do that? Abstract class edible and then fruit extends edible and then apple extends fruit and implement that. Yeah, in theory it's possible. That's why interface acts like an abstract class, but there is a semantic difference that sometimes I have to use abstract class and sometimes I have to use what? Interface. And I tell you what is the difference, semantic difference. Fruit and apple. Is it really a child-parent relationship?
Fruit and apple?
Yes.
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 It is, right?
Right,
Because
it's
apple
different.
really is a child of a fruit, right?
Right.
Cat and animal.
Yes.
But edible is not really a
Okay.
child relationship between fruit and edible. Edible is an attribute, sort of, or property that is assigned to a class, right?
Right.
Edible is not a child class of a fruit, right?
No.
Or other way around, right?
Right.
You assign a property to a class. That's when you have to use an interface.
When the relationship is not directly like.
When the relationship is not a strong child-parent relationship, you're going to use an interface. When it's a strong child-parent relationship, you're going to use abstract class. So that's why you need to use interface. Because edible is a property that you assign to a class. But from hierarchy perspective, it is like an abstract class. And from syntax, you already know what is the difference, right? So fruit, implement. And apple, you should be good about apple, right? Now let's test that. First of all, can I create an object of an interface? No, you cannot. Can I create an object of an abstract class? No, you cannot. Alright?
Wait, we wash the apples off when we eat them.
Huh?
Yeah, that's what I wanted to
That's
ask
what I was.
him.
Never mind. Never mind.
Alright, What did you say?
He said he rinses the apple. You know, you wipe an apple off, you rinse it, it gets rid of the pesticides.
No, it does not. It's deep inside the skin. They say you can soak it in a bleach,
And it's still there. It might as well be in the apple. I forget it. Forget
but
it.
then I don't know. Maybe bleach goes inside the pesticide.
Why would you
Yeah.
soak it in the bleach?
What if you
They say it removes the pesticide.
It doesn't make any sense. The bleach you typically like.
What if you were to pickle the apples in like a vinegar base? That might work, right?
I'm not an expert.
You seem to be. You know a lot about.
I know a lot about food, but I don't know about vinegar with the apple or other substances with apple what happens. But I know you have to be very careful about the food.
Right, I see. No more apples.
Not just apple.
No, let's stop at apples.
Lots of food.
Oh
What if we
god.
ferment it?
Huh?
Let's ferment the apples. The bacteria and yeast will actually eat away at the pesticides.
That's a research subject. I don't know.
You're gonna get to the bottom of this.
All right. So let's create an object here. So apple A1 new apple. Is that okay?
Yeah.
Is that okay? Yes. What about fruit? F1 new apple. Is that okay?
Yes. Except you need to
Perfect. Now, what about this one? Edible, which is an interface, E1, new apple. Yeah, that one is okay. Interface, you can imagine it like an abstract class. What you did before to abstract class, you sort of can do it to an interface. But there are semantic differences. And there are some syntax differences, right? But from class hierarchy, sort of, it is like an abstract class. So can I say A1, system out, print line, A1 instance of edible. Is that true or false? True or false? Yeah, go to the class hierarchy or class diagram. You have to also understand now that this is a fruit. How I show the inheritance like this, right? How I show the interface. Implements the interface. So, is apple a fruit? Is apple edible? Is fruit edible? Yeah, imagine this is like a class, but it's not a class, it's an interface, right? Okay? Now, why they implemented, or why they invented the interface, the history behind that is this. Which they changed it, alright? And we're back in the same place again. So, see here, in C++, you can have a count. Class A, class B. In C++ you have two classes, right? Now, a class C so what that do?
That C is the parent of A and B. No.
Yes.
Wait, yeah.
C
that
is a subclass.
C is a subclass
Okay,
of
that's what I thought.
A
Yeah.
and B.
Yeah.
This is not acceptable in Java. You can't do that. A child only belongs to one parent. Why this causes problem? Because if this is, see, account, checking account, saving, and let's say checking account. Can you deposit in a checking account?
Yes.
Can you deposit in a saving account?
Yes.
is that multiple? By the way, if a class inherits from two different classes, they call it multiple inheritance. Multiple inheritance, right?
But Java don't allow it.
No, Java will not let you do that. Java no. So, is that multiple inheritance?
Yes.
No,
Wait.
it is teach children one
This
parent.
one is a. No, okay, yeah. Alright, yeah.
That's not
That's the
multiple
parent.
inheritance.
Count as the parent.
There's regular inheritance, they have
Yeah.
children for one parent. Java okay with that.
Right.
Java is not okay with that. A
Right.
class inherits from two different classes. See, if this say deposit, which deposit is called? Confusion, right?
Right.
That's why Java stopped this confusion. Java says only one extension, and this one is already extending from what? Let's say object, right? Can I do another one?
No.
Cannot, right? But can I implement an interface?
Yes.
Now, they figure out these Java people, it's bad, but it's not that bad, alright? So let's tweak that into what? Into interfaces, which means a class in Java can extend from one class, but can implement how many interfaces?
Unlimited?
As many as you want.
Okay.
So can I implement 2 interfaces? Yes. Can I implement 10 interfaces? Yes.
I'm gonna edit all into one thing.
Class A, class B. In C++ you have 2 classes, right? Now, a class C so what that mean?
That C is the parent of A and B? No.
Yes.
Wait, yeah,
C is a subclass of A and B.
Subclass
Okay, so I
of
thought-
A and B.
Yeah.
This is not acceptable in Java. You can't do that. A child only belongs to one parent. Why this causes problem? Because
Step
if
down.
this is
B,
C
B, and C. And D.
account, checking account,
Savings.
saving. And let's say checking account. Can you deposit in a checking account?
Yes.
Can you deposit in a saving account?
Yes.
Right. Is that multiple? By the way, if a class inherits from 2 different classes, they call it multiple inheritance. Multiple inheritance, alright?
But Java don't allow it.
No, Java will not let you do that. Java no. So, is that multiple inheritance?
Yes.
Yes.
No,
Wait.
it is teach children one
This
parent.
one is a.
Not
No,
true.
okay, yeah.
No.
Yeah,
That's not
that's the
multiple
parent.
inheritance.
Count as the parent.
There's regular inheritance, they have
Yeah.
children for one parent. Java okay with that.
Right.
Java is not okay with that. A class inherits from 2 different classes. See, if this say deposit, which deposit is called? Confusion, right?
Right.
That's why Java stopped this confusion. So Java says only one extension, and this one is already extending from what? Let's say,
I don't know. Edible.
let's say object, right?
Yeah.
Can I do another one?
No.
No.
Cannot, right?
Mm-mm.
But can I implement an interface?
Yes.
Now, they figure out these Java people, it's bad, but it's not that bad, alright?
Yeah.
So let's tweak that into what?
Multiple interfaces.
Into interfaces, which means a class in Java can extend from one class,
Yeah.
but can implement how many interfaces?
However many.
As many as you want.
Okay.
So So can I implement 2 interfaces?
Yes.
Can I implement 10 interfaces?
Yes.
But can I extend more than 1 class?
No.
No.
No. Good? So that's the story behind that. So, but can I extend more than 1 class?
No.
No. Good? So that's the story behind that. So come here and see. I can come here and say, let's say another interface. And give me some attribute that want to assign to fruit.
Crunchy.
Huh? Crunchy?
Seedless?
Sweet?
What
No,
is it?
an interface that has a method in it.
Oh.
An interface that has a method.
Peelable?
Yeah. Huh?
Honey, was it the dip one? Was it dip apples?
Be creative.
Candy apple?
Huh? Grows on trees.
Candied apple?
But what is the method for it?
Dipping it in
Where to
caramel.
buy?
Pesticide versus not.
Where to buy?
Organic or not?
Wait, were you trying to create a method?
Dipped or not?
Yeah, I'm
Okay.
trying to make methods.
By location.
Get date of expiration.
So by location, and I say public void web. You can buy it from his organic farm. Right?
From Chernobyl.
It's all organic.
All right, where, right? Okay, so by location. All right, so when I come here on the fruit, I can say implements what? Edible, comma, by location. We good? Now there's a small problem there, right? The problem is now this fruit implements 2 interfaces. Each one has 1 abstract method, right? So the class that extends this fruit now encountering how many abstract methods? 2, and you have to implement what? Both of them. So I use the Eclipse help and help me to implement the other one. Apple, I really want. Farm. Alright. We good? And I can implement more than 2, 3 interfaces, 4 interfaces, 5, 6, whatever you want. Extends only 1. Very good? Now, Java people reached to a conclusion in Java 1.8 that hey, even though interface should have only abstract methods, but let's add some non-abstract one to it too. And now it really looks like an abstract class, right? But they call it public default, just for testing purpose, void test. Is that an abstract method? Not anymore, right? Is it inside an interface? Before Java 1.8 you could not do this. Now you can do that. Right?
So the struggle before Java 8.
So that's it, right? You can now use this also test you, alright? Are we good? So we understand the interface, we understand the abstract class. And we know that in Java 1.8 what has changed about the interface, right? You can have non-abstract methods nowadays. So what is an interface? These are the questions they're going to ask you during the interview. And you don't want to miss these ones. Why is an interface useful? How do you define an interface? How do you use an interface? And the classic question they're going to ask you is, what is the difference between an abstract class and an interface? Right? The reason I'm telling you because I know they ask you this question. You don't want to miss these ones because it's your lucky day if they give you a job only with these questions, alright? And they can give you. When you're in school, this question can land you a job. Out of school, no.
They do like different levels of questions, right? They wanna like take out the beginners and ask the easy questions first, medium questions, and hard questions.
Sometimes like that, depends on the company. Sometimes one round of interview, couple of questions, interface, abstract class. They like your behavior, they like your attitude, they like your motivation. Get it done. Binary tree?
That's what you're gonna ask me.
Yeah, binary tree, if you want to go to a really serious company like Amazon or Google, yeah, those are the definite should be there. But not every company will ask you binary. 80% of companies don't ask you binary. 80% of companies, they don't ask you binary.
They make it seem like everybody wants you to know hashtags and stuff.
Alright, an interface is a class-like construct that contains only constants and abstract methods. We know this is not true anymore, right? In many ways, an interface is similar to an abstract class. But the intent of an interface is to what? Specify common behaviors for objects. For example, we can specify that the objects are comparable, editable, clonable, using appropriate interfaces, right? To distinguish an interface from a class, Java uses the following syntax. Public interface, the interface name. This should be like a class name convention, right? Constant declaration, public static final, and what? Abstract methods. Public interface editable, public abstract string how to eat. Can I drop this abstract? Yeah, because interface will put that there. Interface is a special class. An interface is treated like a special class in Java. Each interface is compiled into separate bytecode. So how you see dot class, you will see dot class for interface too. That bytecode, you remember bytecode?
Yes.
Just like a regular class, like an abstract class, you cannot create an instance from an interface using the new operator. But in most cases, you can use an interface more or less the same way you use an abstract class. For example, you can use an interface as a data type for variables as a result of casting and so on. So take a look at this one. It's a nice example. Animal is a class. It has a sound, and the sound is what? Abstracted. You cannot implement the sound for every animal, right? Can you? No. Now, chicken extends what? The animal. Tiger extends the animal. But there is an interface called edible, which we wrote it before, right? Chicken also what? Implements the edible. So if chicken is a non-abstract class, should you implement sound?
Yes.
Yes or no?
Yes.
If chicken is a non-abstract class, shouldn't you implement all the abstract methods for it?
Yeah.
So should I implement the sound, which is an abstract method?
Yes.
Should I also implement how to eat, which you're implementing from edible?
Yes.
Yes. So I have to implement how the chickens make a sound and how to eat the chicken, alright? You want to make sure you peel the chicken.
So tigers on the opposite side because you can't eat a tiger, but
I don't know, if you like it, you can put a line from tiger to here too, but I don't eat tiger.
First you gotta chop off the head of the chicken before you do anything.
First you gotta drink the
Yeah, but that's the first step.
After all the other steps, peel it.
After the chicken is dead, we're talking about that, how to eat it, alright? And fruit. Fruit also, it doesn't make any sound, so you don't need to extend from animal because fruit is not an animal, but you implement what?
Edible.
Edible, and then you have to implement how to eat, but you don't know how to implement how to eat for fruit. That's why this becomes an abstract class, and you leave the implementation to what? To orange and apple. So is orange an edible? Is tiger an edible? Ben, is tiger an edible?
no.
Let me see your class diagram. Maybe it's edible for you. Alright. Is chicken an animal?
Yes.
Is chicken edible?
Yes.
Can you check it for this instance off?
Huh?
You can check it.
Yeah, create an orange and say instance of edible, it says true. Create an orange and make instance of animal, it says false.
There it is.
So we understand this? Alright? Your project work to make the classes interfaces, abstract class interfaces, implementation getters and setters, so work on that one. Create the tables for each one. If you want to persist the data, which means customer data, should it only be in memory or you want to save it somewhere that when you turn off your laptop still there? Anything that is persistent, you put it in the database. When you want to put it in the database, you have to create a table for it, alright? And then you have to write queries to join those tables. People who didn't have database, that's fine. You catch up with the team members. You don't have database? Alright. You are in this team?
No, my team will.
You have database? Yes? Okay. So you can create table?
Yeah.
Alright. You can create ER diagram?
Yeah.
No? That's good. What else?
No, we're talking about this.
Alright, ER diagram. Alright, so yeah, we have 15 minutes, then we have a break. Alright, so you already know public static final for interface and public abstract for every method, but that's not true. You can have a non-abstract now in interfaces, right? Default one, right? Can I drop this public static final? Yes, automatically interface consider that. Can I drop the public abstract? Yes, so automatically interface will consider that, alright? But it's good practice to put them there anyways, right? So are we good so far?
You said you can drop the public static final because what now?
If you drop it, the interface automatically says, you drop it but it is there.
So it still says it's final and static?
Yes.
Okay.
So a K is public static final, regardless you put that there or you don't put that there.
Okay.
But it's a good practice to put it because it makes code very readable. So we good? Alright. Comparable. What is this?
The generic, yeah.
Generic, right?
Yeah.
So, comparable is an interesting one, so let's discuss the comparable, right? Did you have compare to before?
Yes.
In which class?
String.
So what that means?
It's an object.
It checks
It means if you
this
go
object is equal
to
this
class of string,
If the string is equal to string, it returns.
Java 1.8 API, if you go to the class of string, where's the string? Java line object, you already know object, class object. Java line string, does that extend from object? Yes. All implement interfaces, right? All the implemented interfaces. Is comparable one of them. So that means, should I implement the compare to? See? It's an interface, right? It has compare to. If the class string implements this interface, should it implement compare to? And it did that, right? Did it put string here? See here? It is a string, right? So that means, now, this becomes what? A string. So can I compare to a string with a non-string? Not with generate, it gives a compilation error. But if you didn't use generate, and here instead of E it will be what? Object. Can I compare a string with a non-string? Compiler will pass that, but it blow up during the runtime, right? That's why they made it generate, right? So let's do that for fruits. Let's do that. So there are lots of built-in interfaces that you can use, or you can create your own interface. But already I have comparable, so I don't need to rewrite it, right? So take a look here. Fruit. Implement comparable, right? And I put here what? Fruit. So you can only compare fruit with fruit. Now, is this an interface? Yes. So compare to is the method that I have to implement, but it causes a problem for what? For the child, right?
So should I implement the compare to also? Yes, so I come here, I say implement that compare to, but now I have to write the business logic here. Business logic usually is this. If two fruits are equal, you return what? Zero. If you remember the string, you return 0 or a negative number or a positive number. These are just business logic protocol. You're not required to do that, but let's stick to the business logic protocol that every class sticking to, right? So, now the rest is your business logic, what you want to do. So let's say O is a fruit, right? So this, I don't know, I don't have any property for fruit, but let's add one property here.
Should be private and getter than setter. I want to say time, public, what do you want to say? Double, for example, okay? Wait. This doesn't make much of a sense, but I just want to give you an example. I say this, wait, bigger than if. Oh, that way. Then return positive number. Maybe you want to return what? The difference. And you have to make that, oh, you can do that because it should be integer, right? So maybe I can cast it to an int. Are we good now? And else what? Return what? Yeah, the same thing. So it doesn't matter, right? So you can say, let's change it. If this weight equal what? Return what? 0, else what? Return the difference, which is an integer number plus or minus, right? Then I implement some simple compare to. So can I compare one food with another one and get 0 or get a positive number or a negative one? So they did that in a string too, the same way we did it, but with different business logic. And I use interface, which is generic, right? I can't say compare this fruit with that string. See, if I didn't use generic here, which I can, right? Can I drop this? Yes. If I drop this, it becomes generic, which means it becomes non-generic, which means it is like this. So now compare to will get what? An object. Here, this should be what now? Object. And now there's a small problem here because it's an object. Object doesn't have a weight, right? Unless I come in here and say what? Apple A equals to what? Apple. Oh, right? Now everything goes smooth, right? Oh, sorry. And I make that 8. So did I use non-generic? Yes. But there's a problem here because now I can compare an apple with any object. And this will blow up if that object is not what? An apple. So I'm raising the risk of my program to crash during the runtime. When I use generic, compiler will catch that, and there's no way you can crash it based on these typecasting when you use generic. Very good. That's why I use generic. So that's why I come here.
So
yes.
I have a question. So in our project, if you have to put phone number and social security, is better to use a generic, so they can go like
phone number as a property?
Yeah.
No, property is you don't use generic with property. See, this generic should be a class. This should be a class. You can compare. You can make a customer comparable. If you make public class customer,
implements comparable, then you have to implement what? Compare to. And then in the compare to, this becomes a customer because you use generic. Then you can compare this customer with this customer based on the phone number, based on the email address, and say 0, which means two customers are the same, or a positive number or negative number based on whatever business logic you can come up with. But you can make customers comparable, right? You can make tickets comparable. You can make any class comparable, right? You can make class comparable. We good? Alright, so we good with comparable? Sorry, what? To the code? Provide location. You mean by location? Uh-huh.
I had a question actually too. In fruit, were you able to delete those abstract methods because you like resolve them in Apple?
Sorry, one more time. In fruit?
Yeah, did you have override methods in fruit at first, and now they're not there no more because
I have fruit which implements three interfaces. So what about it?
Didn't you have overriding methods in fruit at one point for how to eat?
I did, but it didn't make sense to override because I don't know how to eat every fruit, how I buy fruit from every location. How
Okay, so you just bypass it and then resolve them in Apple.
Yes.
Yeah. Okay.
Correct. I can't resolve it. I give it to child. Hey, resolve it. How to eat it.
Okay.
Alright, so we know comparable. And you already know two-string equals hash code, right?
Right.
These are coming from object and you override them.
Yeah. You told me last time it wasn't a hash code though, but it's a hash code actually.
See, hash code, it gives a unique identifier about an object.
Right.
Okay?
Wait. To two-string of it, the generic, it doesn't give it the hash code. It gives it the unique identifier. I think I'm getting this confused. They're different things. Like when object shoots you out two-string, does it give you the
Okay,
hash code?
I have to talk about hashing, what hashing means.
Okay.
Hashing is a function. You pass something to it, it gives you a unique number.
Yeah.
It should give you a unique number
Right.
most of the time.
Right.
Sometimes it doesn't give you a unique number. So there's a conflict and you have to resolve that conflict. But imagine it gives you a unique number, alright?
Mhm.
So, hash code of an object, if the two references are different, it gives you what?
Different.
Two different hash code, right?
Right.
But when we make the comparison not based on the reference, based on the content, then if two objects, when you say equals, based on the content are equal, the hash code also should give you what?
The same.
The same. So you have to override this one.
Okay.
So in the interview question, if you override equals, should you also override hash code? Always. And you can explain why. That's the typical question they're going to ask. What is the equals behavior of an object class? You already know what it means. Alright? Integer and big integer. See, public class integer extends number, public class big integer extends number, and implements what? Comparable. Most classes in Java implements comparable. You already know what interface means, so that means you have to implement what? Compare to, right? Are you good? String extends from object. You already know everything extends from object. Does it implement comparable? Yes, and it implements more than one interface, right? If you come here, it tells you what are all the interfaces that are implemented, right? 3. Okay? See here, public class date extends object implements comparable. Am I using comparable in all of them? Am I using generic? Did I write comparable one time only? As one interface with one generic. If I don't have generic, should I write interface for each of them? Yes, but generic solves the problem, right? You can pass it during the creation of the interface, right? So take a look here. New integer 3, is that an object of an integer? Can I say compare to new integer 5? Yes. ABC, can I say compare to ABE? Date, can I create two dates and say compare?
Yes, because all of them implements what? Comparable and compared with implemented, correct? Alright. We are almost there. Okay, let's have a few minutes break.
You gotta implement in the sort class where the
Yeah,
sort,
sort array.
In what class?
interface, and then
Put
it
it in
gotta
array.
input, it's gotta implement it. And then
You can put those objects in the array and sort it.
No, what I'm saying is, can I write a method here? Just say public void sort, and I pass something to it that can sort strings, can sort array of integers, everything. You can, yes.
Yes, you can.
But the
Yes.
trick is generic coding. Generic coding is this. See, if I make it array, I can't pass anything else.
Correct.
If I make it string, I can't pass anything else, right? Everybody agree? So, if I want to write generic code, I have to use a generic object or generic something, alright? I can't just put E here. No, E is not for this. E is for classes or interfaces. So, can I pass an array? Which is an array of comparables. I have a problem here because I have to make what?
You have to,
Right?
you don't have to put
Let
implement.
me make it study. Let me see if this works. It still doesn't work, that's fine. Right. I can't make it static here. That's fine. Alright, take a look at this one. Is that a comparable array? So can I start writing code to start comparing and sorting? And when I do an array, for example, first one, for example, do I write compare to? In your sort, did you write sort for integers?
Yeah.
Did you write sorting an array for integers? You did a comparison, right?
Yeah, we
Did
did.
you write sort for strings?
I think we did, yeah.
Yeah.
See,
It's for strings, if you want to write sort, you cannot compare strings directly, you have to use compare to, right? You agree? So one part of your code you had compare to, right? You say if array I compared to array I plus 1, do something, right?
Yeah.
You have some code like this somewhere, right?
Yes.
You agree? Now, if I use generic which is comparable, can I still keep the code exactly the same, but pass an array of integers? Yes. Why? Because integers are what? Gets boxed, right? And then that integer implements what? Comparable. What about string arrays? Each one implements what? Comparable. Anything that implements comparable, can I pass it here as an array and sort that?
Yes.
Yes. Generic program, I write sort one time, and I can pass different arrays. The condition is what? That array I pass, the members implement what? Comparable.
So it's better to write like this, or our project we can just test with everything.
You tell me, is it better to write one time or write 10 different times?
10 different times would be better than one time.
Some different times if you want practice.
Yeah, for practice, yes, but in real life, you want to write it one and which works with everything, right?
Yeah.
See, what can I use to sort? Do I have arrays? Sort, right? So see how many times you wrote the sort? Many times, right? Alright. So I didn't use generic programming here, right? You can write it one time. Or you can write it different times with different types. Okay? So you understand the generic programming. Why we use interfaces and classes and using it as a generic type here. You got it? Alright? Now let's get to alright, so take a look at geometric object. Rectangle extends from geometric object, and then comparable rectangle which you create, it extends from rectangle but also implements what? Comparable. So these are rectangles that you can use compared to on it, because they implement what? Comparable. Can I use it on this one? No, because I don't implement comparable, right? Are we good? So can you write that at home? Geometric object, rectangle, and extend comparable and implement into this interface comparative? Yes, you should be able to do that. Alright, now we're going to get to the clonable and copying. If copy, shallow copy, right? That's important and a little bit complicated, so let's discuss that, alright? Alright, new class. Alright, clonable. Clonable is an interface in Java. First of all, what is cloning? Can someone explain cloning to me?
Creating an exact copy.
Correct. If I want to create an exact copy of same person, same object, whatever, that's called cloning, right? Now, let's get to create a class here. Let's say house. If I want to make house, if I make an object of house, it's easy because I can use the default construct and create an object, right? Let's add some properties here. And let's use it public, even though it should be private, setters can get there. Public, let's say double area, and public date create. Alright?
To import date, right?
Yes. Import Java utility. Are we good? And alright, that's good. Now, can I create an object of house? Let's make a constructor public house area, sorry, double area, and date created, and I will say what? This dot area equals to area, this equals date created equals date created. Alright, we good? Okay. Now, can I create a house object? Yes, I can, right? How can I do that?
House.
I come here and say house H1 new house, and I just say 1000 and a new date. Are we good so far? Alright? Are we good? Now, can I clone this house? No, I cannot. The only way I can clone it, you have to follow this rule in Java. You have to say.
So when you say you clone that house, you're gonna have two objects
Yes.
called H1?
You can clone that house H1 and make another one that looks like an H1 one. But I cannot do that until I follow this process. I have to first implement clonable. Clonable is an interface in Java, and they call it marker interface. Marker interface is an interface that is empty. It doesn't have anything in it. So why they call it marker interface? Just to check mark a class that is implementing this, alright? Now, so the first step is what? To make the class implement clonable. The next step is public object clone, and it should be, that's pretty much it. Alright, so this clones, and I say super, there is one thing missing. Oh. about this part I wrote here? This is chapter 12 we're going to talk about, alright? So, did I create the clone method that returns an object? And you already know what super means, right?
Yeah.
Super means go to the parent. Where is the parent here?
House.
Clonable.
Clonable.
And call the clone on it. But it doesn't have anything, so Java knows how to deal with that when you say super clone, right? And it clones the house for you, right? That's the process you have to follow. Implement clonable, and then public object clone. We're going to talk about that, and then return super clone. We good? For every class, if you do that, it makes it clonable. Now, if I come here, I can now say house h2 equals h1.clone. Again, don't worry about this part, just leave it. Just leave the, oh no, sorry. Don't worry about that one, that Eclipse puts that there, we're going to discuss that. But see, when I say h1 clone, does it return an object? Yes, because if I come to the house, where's the house?
So if you put
Is that an object? Yes, but in reality it's what type? It's a house type, right? So that's why I cast it to what? To a house. So I cloned it. Are you good?
So if you did like h2 dot area, you get 1,000.
Yes. But there is a catch here. So let's talk about the catch. So let me come here and change it first. Right. Do you see this house? So you understood the process, right?
Yes.
Now, how the clone works of this super, you know how it works? It copies one by one the fields from the target, from the source to the target, which means if I look here in this test, will it copy from H1 area to H2 area? Will it copy from H1 date to the H2 date? That's how it works.
Well, one by one.
One by one, it copies the value from one to the other one, from one to the other one. This is called, write it down, shallow copy. Shallow copy. If I copy from here to here everything, they call it shallow copy. It's a problematic sometimes, and let's see why. So it's called shallow copy, right? So the behavior of the super clone is what? Shallow copy, right? You see this? This does a shallow copy, which means it copies one by one from source to the target. The problem is here. See, area. Look at the house area. Is that 1,000? So if I copy from here to the area of H2, it will be 1,000, right? And these are two different, 1,000 here, 1,000 here. You're good, right? We're good, right? Now, the problem comes here. Is that a reference?
Yes.
If I copy the reference from the source to the target, they have the same reference, but they point to what?
The same place.
Same object, right? So if house 1 changed that, will H2 see the change?
Yes.
Problem, right? It's not a real clone then, right?
No.
Clone means when I clone from here to here, these two have no binding anymore, but they have exactly the same values, right? So if someone changes here in this cloned object, should I change this one too? In real clone,
Yes.
no. It should not, right? If I clone a house from here to here, if something changed about this house should change too? No, that's not a real clone, right? Now, if you do shallow copy and you have references, you have a problem there. And I can easily prove that to you. Because if I come here and I say, change the H2 to what? Area to 2,000. Did I change H2 area to 2,000?
Yes.
System out,
H1.
print line, and if I say H1 area, what gets printed?
2,000.
1,000. It's the primitive stuff. I just copied from here to here. So if I change one of them, the other one will not change, right?
Yeah.
The problem is about the reference.
The reference, oh yeah.
So when I run this, I still get what? I still get the 1,000, right?
Yeah.
But if I come here and say what?
This Cause that's like double referencing, right?
What is double reference?
Well, you're referencing the date, and then the H2 is referencing the date class.
H2 is referencing the object of date. And H1 is also referencing the same object of date. So now if I come here and say set hour to 10. Did H2 go to that object of date and change the hour to 10?
Yes.
If I use the area, will I see the change now to 10?
Not the area, the date, yeah.
Get hour. I run it, you will see that there's the change. 10. Problem, right?
Problem. Huge problem.
So when you do a super clone, it does a shallow copy. If you have only primitive types, it's okay. But if you have a reference, it's a problem, and now you have to do a deep copy. How you do deep copy? It's easy. Come here and see how we do the deep copy. Did this one do a shallow copy for you already?
Yes.
So I'm not going to return that object because the object is a shallow copy one, right? I come and say do the shallow copy, but now change what?
The object reference.
Change. That's not how it works. So I say object obj. Is that the cloned one?
Yes.
But is it a shallow copy one?
Yes.
So let me even make that. When I clone, do I create a house? Yes, right? Everybody agree? And I can come here and say the house, right? So is that a shallow copy one?
You always have to cast it into a house option?
I don't, but because I want to access some of the properties of this house. If I have an object, I cannot access it during compile time, so that's why I cast it. So is that the shallow copy one? Yes. And everything is copied one by one, right?
Yes.
But in order to break that link, can I come here and say object date created what? So now
You get the clone and
I
you get
created
the
a
seven
brand
date.
new reference for this cloned one. So
Yeah.
now it's pointing to some different dates.
Yeah.
So either one change the dates, the other one will not change. So in the deep copy, should you create a brand new reference for each one? Yes. And do I have now an object which is deep copy?
Yes.
Return what?
So you must do shallow copy before you do deep copy.
I do always shallow copy because all the primitive type I want to copy it immediately.
Yeah.
Can I ignore this and do one by one everything myself? Yes. But when this does the shallow copy for me and I have to just touch the one that I need to deep copy, why not using this utilization of this clone, right?
Yeah.
So do you understand the deep copy, shallow copy?
Yes.
Implement clonable, then public object clone, and then super clone does a shallow copy. If you have a reference, you have to do a deep copy, which means you can't sync the references. You have to create a brand reference for the cloned object.
So would it be like that with,
Huh?
would it work like that with like objects, strings, arrays?
All of them are deep copy.
All of them.
You have to, all the
You have to
references should be
deep
deep
copy.
copy. For string, do you need a deep copy?
It's not a primitive type, so yeah. Yes, you do.
You sure?
No.
Why? Why not?
Because string is immutable. If one of the cloned one changes, it will not affect the other one, right?
Oh my God, it's
There's so many details just sneaking in. We don't have to do that whole string.
No,
For-
because string is immutable, right? Even though it's a shallow copy, which means both references point to one place, can one change the other one, and the other one see the change?
No.
As soon as this one is changed, it creates another one. We good?
Yes.
Alright.
Trick us pretty good on that.
Alright, interface versus abstract, these are the differences. And remember the differences because I'm going to also ask you the question. Abstract class, do we have variables? No restriction. What about variables for interface? All should be public static final. Constructor. Constructor. Does abstract class as a constructor? Yes. What about interface? No constructor for interface. What about method? No restriction. You can have abstract, non-abstract. What about interface? All of them should be what? Abstract. But Java 1.8 changed that, right?
Yeah.
Now you can have abstract and what? Default one, which is a non-abstract one, right? Interface versus abstract class, you already know what this means, you already know what this means, right? So what this means? Implement. What about this one? Extend. Is class 2 an instance of interface 1_2? Yeah, just follow the link and you see that this is a type of this, right?
Yes.
Alright, very good with this?
Yes, we're good.
Conflict interfaces in a rare occasion. Isn't that the problem of the multiple inheritance also? In a rare occasion, a class may implement two interfaces with conflicting information, two same constant with different values, or two methods with the same signature.
Yeah.
Same problem comes to interface, right? So really Java didn't solve that real multiple inheritance problem. This type of error will be detected by the compiler. You can't have it because it doesn't know to eat or how to eat is coming from which interfaces. Both of the interfaces have how to eat, right?
So as long as they have the same name or just the one signature?
Same signature. Then you will figure out there's a problem, you have to change it, right?
Yeah.
Alright, where to use an interface or a class? You already know. Strong relationship of a child-parent, you're going to use what? Class and abstract class. What about if you want to assign an attribute or a behavior to a class? You use what?
Interface.
So you have to elaborate on those. What is the syntax difference between interface and abstract class, and what is the what? Semantic difference. Why I need to use abstract class, alright, or interface. Alright, this one you can look at in the book. We don't have a rational number in Java. Rational is what? You have numerator and what? Denominator, right? You can create a class and say two properties. You remember rational number?
Yeah, 1/2.
Yeah,
3/4.
5/4, right?
Yeah.
You don't have a number like type that in Java, but you can synthesize one with a class. You say, I have a rational, it has two properties long, and using the constructor you have to assign those, and then you can implement what? Add, subtract, multiply, and divide for rational. But you have to implement the business logic here. And then you can create rational numbers and add them, subtract them, so now you have a type. Which you invented that type. Java doesn't have that, right? So read about the business logic, and GCD, see? You give those two numbers, and it gives you what? The GCD, right? Okay. Designing a class, these are some guidelines, I think we have done sort of. So, a class should describe a single entity. Single entity. Which means it should not do this and that, two different things, right? Concentrate on one single entity. All the class operations should logically fit together to support a coherent purpose. Customer, ticket, flight. Customer and ticket together, no, right? You can use a class for students, for example, but you should not combine student and staff in the same class because student and staff have different entities, right?
Yes.
Like how the table goes in the database. You don't mix the tables, right? A class should... Okay. A single entity with too many responsibilities can be broken into several classes to separate responsibilities. So don't write a class with a lot of methods. If you're writing a class with a lot of methods, you can definitely break that down into two classes. The classes string, string builder, and string buffer all deal with strings, for example, but have different responsibilities, right?
Yeah.
So they broke down string into string, string builder, string buffer. They didn't merge them in one big class, right? Alright. Alright, so there is a small difference between string builder and string buffer. We want to explain it later, not now, alright? Classes are designed for reuse. User can incorporate classes in many different combinations, orders, and environments. Therefore, you should not design a class that imposes no restriction on what or when the user can do with it. Design the properties to ensure that the user can set properties in any order with any combination of values, and design methods to function independently of their order of objects, right? So when you have a class, you should not count on user will create first an object and then call this method and then the other method. You can't count on all those stuff. They should be independent methods, right? provide a public no arg constructor and override the equals method and toString method defined in the object class whenever possible. Most of the time we override these ones and provide a no arg constructor because some of the tools it uses no arg constructor, right? Just provide that, it's no harm, right? Follow standard Java program style, choose informative names for classes, data types and methods. Always place the data declaration before the constructor and place constructor before the method. Always provide a constructor and initialize variable to avoid programming errors. Alright, everything should be private and you have to add getters and setters, right? You already know that. And that's pretty much it.
But if you want to
And if the property that is shared by all the instances, you should do what? Static. Alright, this chapter is done.
protected if we use it, if we want to access it from the subclass.
Protected, you can access a subclass anywhere you are, inside the same package, outside the package. But if you make it package access, what will happen? Only inside. So which one is more restricted?
Right? What do you mean?
Which one is more restricted?
Private.
Protected or package access?
Package access.
It's more restricted, right?
Yes.
Yes, more restricted. Because even you are not in the same package, you cannot access it under any condition. Protected, if you're a subclass, you can access it, right? So default is more restricted, right? Or package access. Alright, we're done. So let's get to the chapter 12.
Yeah, no. It's not that bad. It's just, oh, you just need to try and catch it, bro.
Yeah, it's easy. It's very easy, alright? Alright, so. And your.
No, it's not.
No, it is easy.
In overall.
Well, the first part is easy, but.
Alright. Let's discuss it, then you will see it's easy one. Alright? Alright, you wrote program. You wrote a lot of programs. Sometimes it crashes. You saw those red lines, and that's the end of the story. Your program, under no circumstance, will crash. Have you seen the blue screen?
Yeah. It sucks.
Never seen blue screen? You have a Mac?
Yeah, fair.
No blue screen.
No blue screen.
What is that?
You just need to death when the computer crashes and it stops. It just turns off.
Sometimes Mac crashes too. I've seen that.
Yeah, mine just turns off and
I don't know if it's Mac crashes sometimes too. Hangs.
it just hangs.
It
freezes.
hangs.
Yeah.
And I have to kill everything.
Yeah, then you just
Anyway,
force
the
them.
program should never crash. So if you write something like this, a equals 10 and int b equals 0, and then you say, alright, system out, print line a divided by b, your program will crash. The compiler did not catch any problem. As soon as you run it, end of the story of the program. Let's take a look here. It tells you exactly which line has a problem, alright? Alright, now, in order to understand that, whenever the program has a serious problem, you can imagine this line of code. So which line is causing the problem? Not this one, not this one, this one, right?
Yes.
Whenever a line causes a serious problem, you can imagine that line throws a stone, a hard stone, to the air, alright? Up in the air, right? If that stone gets out of the main, it makes your program to crash. So you have to catch that stone in order not to fly out of the main. If you let it fly out of the main, it hit the window, crash, alright? So you have to stop it from hitting the window, alright? So is this line throwing a stone?
Yes.
Is anybody catching that? No, it's going out of the main and crashes, alright? So, in order to catch that stone, you're gonna say try, which means I'm gonna put a safety net, and if any stone comes out, this net will what? Catch it. So put a net around this code, and if the stone came out, just catch it. Now we're going to talk about what this means, exception. That stone is called exception in Java, alright?
You gotta do something to the cat.
And then when you catch that, when you caught that stone, it comes inside this block and you can do whatever you want to do. Or you can just leave the stone there and that's the end of the story. It didn't get out of the main, it didn't crash. So maybe I just have to put a message here for now.
Invalid.
Print line. Something went wrong. Or I caught a stone.
Just understood.
Yeah, I was about to say it too.
It's not that self
I did that when I was.
it's not good explanation of what's causing, but I'm just explaining to you. There is a chance there's stone being thrown from here, or exception, and there's a safety net around it, and when it catch the stone, it just dumped that stone where? Inside here. What did I do to that stone right now? Nothing. I just left it there, and I print a message here. So now, will this program crash anymore?
No.
Not anymore. That stone will be caught in that catch block, and it prints what for you? I caught a stone. You good? Alright. Now let's have a little bit more technical term. That stone called exception, alright? You can imagine this stone as an object. I said stone, but imagine it's an object, and that object called exception. Alright? So I'm not throwing a stone, I'm throwing what? An exception. Okay? I said it's an object, right?
Yeah.
So every object is a type of a class, right?
Yes.
So what class this object originated from? I don't know, but I have the class hierarchy. So let's take a look here.
Yeah.
In Java APIs.
In Java, everything is an object, exception is an object, so you have to know that object that line shows is which one. It's object of which class. But look at the hierarchy. Arithmetic exception, null pointer exception, other exception. Are they extending from runtime exception?
Yeah.
And all the other exception, are everything extending from an exception?
Yeah.
So can I say every exception, regardless exactly what type is it a type of an exception?
Yes.
I can say that, right? Okay, so if the stone or that object being thrown, the first thing it does, it comes here, say, am I a type of an exception? Am I or not?
Yeah.
Yes.
This net will catch that.
That's what's gonna happen.
So if I make that arithmetic exception, then when this object flies, it comes here again. Am I type of arithmetic exception? Well, in this case it's yes, it still will catch it. But if I make that as a null pointer exception, well, that's not a null pointer exception. It comes here and say, am I a null pointer exception object?
No.
I'm not going to catch. So that stone flies where?
Out of main.
Out of main it crashed. So if I put an exception here, is the safest bet?
Yes.
Yes, because any stone or any exception being thrown, it is a type of an exception, it will be caught, right? Do you agree? But sometimes, I don't want to lump every stone or exception I catch in one net. I want to have 2, 3 different nets because I want to act differently on those different exceptions. So in Java you can have more than one net, which means you can have more than what? Catch. So if this net catches this stone, I want to say your math is not good. The other one says something happened. See, I'm taking 2 different actions based on these 2 objects. Now this is a very simple example, but sometimes in industry you want to really do something completely different. Message the user differently, or do something in the database. You want to do different actions. You don't want to treat every exception or a stone the same. So now what will happen? A stone or an exception being thrown here, it comes to the first net. Am I arithmetic exception? Yes. I'm going to come here, I leave the stone here, I'm done with the catches. I'm not even going to check the next net. When one net catches, that's it. No other net even try. So do I print your math is not good?
Yeah.
And that's it. Does it continue after all the catch ones?
Yes.
It continues after all the catch ones. So maybe I want to try to put a done there too.
Done. So what will print here? Your math is not good, the net caught the exception, and I've continued after all the nets, which are all the catches, and then I print done. Now, do you remember array? Hopefully, yes. If I say new int 4, and then come here, and say array 10. You don't expect to know every different type of exception, but there are a couple of them very famous. Arithmetic exception is famous. This one, I'm sure you saw it a lot when you wrote code. So by now you know it is array out of bound exception, alright? Now take a look what will happen. These are put behind the net to catch the stones or exception. Will this throw an exception?
Yes. No, this one no.
Will this one throw an exception?
Yes.
So a stone or exception being thrown, it comes to this net. Is it that a type of exception? It catches that, print the message and continues here, right? That's it. What happened to this one? No, as soon as this one thrown, it goes through the net, checking the net and continues after that, right? Now if I change that, will this line cause a problem? No. Will this cause a problem?
Yes.
It's what type?
Out of bounds.
Out of bounds. So it comes to the first net. Is it arithmetic exception?
No.
Is it an exception?
Yes.
Everything is an exception. So this is a net that we really catch everything, right? So something happened, you're done with all these catches, you print what?
Done.
Done. So you can have more than one catch, but you have to make sure your stone eventually will not get out what? Get out of what? Name. So usually you put different exception on the top, and then you put one exception at the end. Yes. And it doesn't make sense to change the order. Why? Because obviously you will know why there's a problem here. Because any stone gets thrown, will this net catch everything?
Yes.
And never gets here, right? So that's what compiler also give you, that this is unreachable code. You can never get here, right? So order is important, right? Alright. So we got the main point of exception. Oh, we have 7 minutes. Is there any question about exception so far?
Do you have to call it like, I mean, do you have to, let's say you have 3 methods, do you have to like, on every method you have to?
We're going to talk about that. So far no exception, no problem?
What about the keyword pairs?
We're going to talk about that.
Okay.
Alright, so far you understood this, right?
Yes.
Alright, let's go back here. I don't think I can finish it, but let's explain as much as I can. Is this part of your assignment?
Yes.
And assignments due this weekend?
Yes.
Okay, I might extend it for 1 week. Alright, so look at the exception class hierarchy. Huh?
That's a great idea.
Yeah, it's organic. Alright, look at these classes. You don't need to remember everything, but arithmetic exception you already know, array out of bound exception, index out of bound exception you already know, right? Alright. Null pointer exception. Do you remember this one?
Yes, it's
You
when
have a reference which is null,
No,
and you're trying to dereference it with a dot, right?
Yeah.
Circle is null and it says circle get area. Boom, null pointer exception. All of them are runtime exception, which means it might happen during the runtime, right? So you see, these are extending from what? Runtime. There are some exception that is not runtime. Compiler sort of catch them, right? We didn't discuss any of those, but just keep that in mind for now. But everything, regardless is a runtime and non-runtime, extends from what?
Exception.
Exception, right?
So those we really have to put, right?
We're going to talk about it. An exception extends from what? Throwable, and throwable extends from what? Object. And you also have an error class, which when error happens, it's the end of the story. You can recover from it. Something crashed fatally, and that's the end of the story, right? So we don't deal with this stuff. See, these are recoverable. They're not that bad, but these are our problems, serious problems. Okay? So these are called exceptions. These are called runtime ones. And by the way, they call runtime ones unchecked.
So runtime, unchecked. The other ones are what?
Checked.
Checked ones. So you have checked, you have unchecked. Unchecked means runtime. So far so good? Alright? Runtime exception, error, and their subclasses are known as what? Unchecked exception. All other exceptions are known as what? Check exception. Meaning that the compiler forces the program to check and leave. Why they call it check exceptions? Because can this cause an array out of bound exception? Is that a runtime exception? Runtime exception means you don't need to catch that. Compiler is not forcing you for anything. So can I write a code like this? Did I write a code like this? With compiler tell me, hey, you have to write try and catch. Anything that is runtime potential of throwing a runtime exception, compiler will not force you to put it in a try and catch. If it's a checked exception, compiler says you have to write it in a try and catch. So if it's IO, do I need a try and catch in
Yes.
for sure? Is this one I need?
Yes.
Or the other these ones?
No.
No, you don't need. No need means it's up to you to put it or not to put it. Now, is it a good thing not to put it? No, it's not a good thing. But compiler doesn't care. It doesn't enforce you. All right? That's why they call it unchecked. The checked one, compiler says, I'm going to check that. You have to put that there. All right, I don't think I can finish it, so I finish it next time. So I stop here. And I extend the assignment for 1 week. And now you have 1 week. I want to make sure your database is set up for next time. Everybody should have a local database on your laptop.
By Monday?
I don't force you to use MySQL. If you want to use any other type of database, if your team is comfortable, go for it. If you want to use Oracle, that's fine. If you use SQL Server, it's fine. Those have a free version, trial version. So if you go with the no MySQL, it's other setup is on your own, all right?
So you want that by Monday?
Yeah, it's a matter of half an hour to install it.
It's not even half an hour. If you have a decent internet, you don't have that thing.
Okay. I always give extra time, you know that, right?
Hey, I'm just
Not
saying.
always. Today you didn't.
Always.
And he gave us a minute.
Oh, yeah.